To illustrate the point of the fact that large numbers don't always necessarily have to go on the top of the fraction when you're doing conversion factors and dimensional analysis, we're going to look at this problem here. How many years old is a person who has lived 7,889,400 seconds? Again, I would encourage you to work along with me and ahead of me and pause the video and try to do the work, and then start it and see if you did it right, and then pause it again and watch it again and try to understand. So we'll start by asking ourselves, what are we starting with? We're starting with this big number of seconds, 7,889,400 seconds, and we're trying to end with some amount of years. Okay, so that gives us a starting place and a target to get to. So I'm going to break this up into a couple of blocks, break our fraction bar up into several blocks, and we always start down here on the left hand end. This is a whole number over 1, so I'm going to put it on the top part of the fraction to begin with. And right away I know I'm trying to go into larger amounts of time, larger time units. So seconds, what can I get that to be? Seconds, I know how many seconds are in a minute. There are 60 seconds in a minute. Now, in this case, I'm trying to cancel out seconds and end up with minutes because I'm making my way toward years. Years needs to be in the top part of all this when I'm done. So I need minutes to be in the top part here so that seconds can cancel out. 60 seconds is the same as 1 minute. Now you'll notice here and here seconds will cancel out. 60 did not go in the top part of the fraction because 60 needs to go where seconds goes in this case. And if 60 goes in the top part of the fraction, it's going to say 60 minutes for 1 second, and that's not true, and it'll lead you to the wrong answer. So put the number that's appropriate next to the unit or the letters that it's supposed to go with, and put the letters where they're going because you're trying to cancel them out with the ones from the previous fraction. Top and bottom, same letters will cancel out. Now, I cancel out these letters. Seconds cancels out with seconds. Now I need to deal with minutes, and I'm trying to get to years. I know that there are 60 minutes in an hour, so I'm going to do this again. Minutes needs to cancel out with minutes, so 60 minutes in 1 hour. Now I have canceled out minutes, and again the 60 minutes went in the bottom of the fraction because I'm trying to make it cancel out with the one from the previous fraction. There's 24 hours in a day. And that hours will cancel out with this hours. And there are 365, I'm going to give myself some extra space here, 365.25 days in 1 year. And that will get me to my final answer of years. This hours will cancel with this hours, this days will cancel with this days, and now all I've got left in my letters is years. And so now I know I'm finished with all the factors I need, all the fractions, the conversion factors I need in order to get my answer. So to get my final answer, I multiply all the top times all the top. It's this number times 1 times 1 times 1 times 1, which is not going to change that number. So I'm going to come down here. That's going to give me 7,889,400 years divided by 1 times 60 times 60 times 24 times 365.25. So 1 times 60 is just going to be 60 times 24 times 365.25. It's going to equal 31,557,600. 31,557,600. Now there's no unit because they've all canceled out. So what I'm left with now is I will divide this fraction, top divided by bottom, and that'll give me a decimal for my final answer. And I'm having to make this curl all the way around the world to get there, but anyway. So I'll just clear that out, type in my new number, 400 divided by 31, 557, 600, 0.25 years. That's how many years a person has been alive if they have lived for 7,889,400 seconds. So they're not even a full year old. They're 1/4 of a year old or 3 months old. And we could do a little conversion factor to make that too. Hope this is helpful.